F dummy is a 15 days. Likewise, P2, A, dummy, D, dummy, G, that is equal 14 days. If you look at all these things, you see only the critical path, D, E, F, it's take 20 days. Because that is the longest path, is the critical path of the project, right? In both ways, we can calculate, right? By diagram also directly calculate, and after checking the path also, we can calculate. So, in some diagrams, there are 2 or 3 critical paths. Some diagrams, there may be only one critical path. Definitely, there is at least one critical path should be there. That is a must, right? Sometimes, some network diagrams, there are more than one critical path. That is also possible. So, therefore, you have to keep it in your mind. The critical path may be more than one. One must be there at the same time. Some networks or some diagrams may be more than one. So we have to carefully look into that while we are making decisions. So the critical activities create the critical path, right? Critical activities of the project creating a critical path. According to this, B, E, F are the critical activities. So these critical activities creating the critical path. Okay, right. So the normal durations calculation, normal cost calculation, that is also very simple, because just we have to add all these uh, individual activity cost normal time or the normal cost plus the project completion is 20 days. Therefore, 20 has to multiply by 1000, that is 20,000, right? 20 has to be multiplied by 1000, right? That's why 20 days, right? If you are multiplied by 1000, 20,000 plus 40,000 become as a 60,000. Here, direct cost 40,000 plus indirect cost 20,000. Indirect cost means site cost or fixed cost. Direct cost mean activity cost totals. Altogether, we can get a 60,000. Okay. So therefore, the normal durations 20 days, normal cost 60,000. You have to understand within this normal cost, there are two components are there, 40,000 plus 20,000. This is a direct activity cost. That is from the table, summation of all these normal costs, 4,000 plus 765, all these things become as a 40,000, right? In addition to that, 20,000 is a fixed cost or the indirect cost, right? All these things we have to consider for the normal cost calculation. So the normal cost calculation, there are two components, right? Sometime even if your network diagram sometime error, if you find the activity duration, this calculation may be correct. Be careful, huh? Sometimes your network diagram may be wrong, but if you somehow you have found the duration of the project, then you can calculate or you can get the marks for the normal cost. That is also possible, right? Sometimes. Okay. So this is a basic thing. So far you have learned, I'm refreshing what we have learned on 6/12/2000 regarding network analysis, right? So we know that normal, we have to know about how to do the network diagram with the normal durations. That is the one thing. Then you have to understand what are the critical activities of the projects, what is the critical path, what is the normal cost of the projects. Within the normal cost, there are two cost components. One is fixed cost or indirect cost or the site cost. Right? In this example, it is 20,000. In addition to that, there is a direct cost relating to each and every activities of the projects. That is 40,000. So we have to add 40 plus 20 to find the normal cost of the projects. So this is it's a basic things, right? So there are three levels of analysis here, right? Normal things, normal cost. That means normal duration, normal cost, right? So this is very easiest one, right? This is very relatively easiest one, right? So anybody can deal with that. So therefore, students, you don't get to panic or fear for this exercise or for these sections. You have to develop your confidence and hope. I can first familiarize with the normal duration, normal cost. So after that, you can think about how this process is happening, right? You see, this is the network diagram for the normal durations, 20 days, right? So a lot of insights are there, right? Critical activities, you can able to differentiate what are critical activities, what are non-critical activities, right? So in these projects, critical activities are B, E, F, right? A, C, D, F, sorry, A, C, D, and G are non-critical. And also there are three dummies. Dummies, there is no cost, no time. That is a basic principle regarding dummy. Only for drawing purpose, we are using dummies. Okay. Only for the drawing purpose, we are using the dummy. Apart from that, there is no any other meanings, right? To make the network diagram smooth drawings, we are using dummy. That is the predictions. That is the basic things. Okay. And therefore, then I have shown to this chart, Gantt chart, right? You see that this durations days, I put it in the horizontal axis. Activities, I put it in the vertical axis, right? This is days, right? All these things are days. Can you see, students?
Yes, sir.
Okay. This is days. That means durations of the projects. Duration of the projects in days, right? Same information. You see that one is diagrams, the other one is I put it in a table. The same informations I put it in the tables, right? You see to easily understand the realities. So the duration of the projects in days, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So A, how many days it take? 4 days. They are focused activities A. Then I'm going in that order. You see that first A, 4 days. 1, 2, 3, 4. There is no any preceding activities. B is also no preceding activity starting from 0. That takes 7 days. 1, 2, 3, 4, 5, 6, 7 days. C also there is no preceding activity. You can refer the tables. Right? Take 6 days. 1, 2, 3, 4, 5, 6. Right? Then after that, D. To start the D, you can refer the network diagram. To start the D, we have to complete all these things. A has to be complete, B has to complete. So therefore, B is finishing here, exactly 7 days. From that place, B is starting. So that order you have to consider. There are preceding activities. If there are preceding activities, where we have to start. If there are preceding activity, where we have to start, that origin, starting place, you have to carefully understand it. Where this longest path is finished, where the longest path is end, from that right point, right, other preceding activity, because C, B and A are preceding activity. You see the table, you can see original table. A and B are preceding activity for E, right? So therefore, while we are starting, right, therefore while we are starting, we have to carefully look into where we start. So the D is starting from here. Similarly, E is also starting from here, because for both this is a A and B are preceding activity. B is ending here. So that is about 1, 2, 3, 4, 5, 6, 7 days for E. Then you see F. For the preceding activities, you know for the F, 3 activities. I'm going here and there. You have to remember your notes. C, D, E. C, D, E. Right? After finishing C, E, and D, right? You see here in this table, C, D, E. E is finishing here. So this is the longest part. Then next F is starting. At the same time, G also starting. It will take only 5 days. This is 6 days. Therefore, G is finishing here or ending here. So now you see I noted small arrow mark, black color arrow mark, where B is a critical path, E is a critical path, and F is also critical path. So you see that really starting we starting from here and stop here, then it's go here, then it's come here, then start from this to here, right? Okay. This is the order. So that's make critical path. So in both way you can check, right? In both way you can check the feasibility. So then you have to clearly understand the normal things, normal course. Then it will useful to understand the latest thing, crashed and etc. Okay, give me a 2 minutes. Huh? Okay, students, any doubts regarding this one? So you have to look into any problem, you have to look into multiple views. So this table also, so this table give a lot of information. How many days we can delay for the non-critical activities. Say for example, you see that this one, C can delay by 1 day because there is a 1 day gap is there. A can delay by 3 days, right? 3 days, you see. So these 3 days we can delay, right? So A is only 4 days needed. So we can start from here and complete here, right? How many days we can start activity A by late? How many days by we can late? Activity A, how many days we can delay or we can late? Hello students, how many days we can delay the activity A?
3 days, sir.
Okay, 3 days we can delay. Similarly, C we can delay 1 day, no? Right? All these things already I have explained. I'm explaining this third time I think, right? D can delay by 2 days, right? D can delay by 2 days. G can delay by 1 day. So therefore easily we can understand rather than this one, network diagrams. That is advantages of placing all this information in this table like this, table chart like this. It's called Gantt chart, right? So if it is 40 days, 50 days, it may be difficult. Because small example we can put and try to get our real understanding or realities about the projects. Okay, right. So that is the advantage of this doing the chart. And this is other way of network diagram is other way of one primary way of understanding the durations. And also that by looking at the individual path, we can see the durations, each path durations, P1 how many days, P1, P2, P3, you can decide it. It's not text. Definitely this should be there is no necessity. The P1, this first path should be a P1. It may be P5 also, that's possible, right? So that for my way of doing, I have considered P1, this path as a P1. But altogether there are 10 paths, right? So the name should be different, right? So altogether 10 paths and individual path durations also given, right? Individual path durations also given. Okay, and right. So these are the basic things about the normal duration, normal cost. Then we are moving. Any doubts on this normal duration, normal cost? If you have anything, you can put it on a chat or you can ask, no problem there. Before we move into crash. Do you have any doubts? That's what will happen if you are delayed students?
Yes, sir.
What will happen if there are delays in critical activities? The students, what will happen if there are any delays in critical activities? Project duration will increase, right? If there are any delays in any critical activities, the project duration will be increased, right? The project duration will be increased. Okay, that is the results. So therefore, you have to think, right? So what is happening? What is the status of critical activities and non-critical activities? Everything. Yes. The second part of this project is the crashing. Crashing means basically it's a reducing the durations, right? So reducing the durations. Crashing means reducing the normal durations. Sometimes the project owners, right, or the project owners may negotiate. Okay, they need something has to be urgently opened. Sometimes building today is a new year. Some people may plan to open their building is on New Year time or New Year day, January 1st, 2024. Sometimes, therefore, they have to complete the task quickly. So there is a need for crashing, reducing. While we are crashing, we have to consider about two parameters. One is the duration, other one is the cost. Right? So other one is cost. Again, the cost also there are two aspects: fixed one, direct one, and indirect one. So while we are crashing the duration, say 4 days work, we are going to finish it in 2 days. Then we need extra manpower, extra machineries, right? Extra energy and etc. is needed. Therefore, it has extra cost. Right? Therefore, it takes some extra cost. Okay. So that's why normal duration and crash cost are increasing when compared with normal duration. You see, it is a 4,000 is 6,000. Duration is reduced because it's directly related to the activities. Because it's directly related to the activities. Directly related to the activities. 4,000, 6,000. Right? You see that. So just if you divide it by 2 days, then per day increase is 1,000. Right? Per day increase is 1,000. So this is the idea behind the crashing or reducing the durations. So while we are reducing the duration of each activity, then normally the project duration will be reduced. Okay. So you have to carefully. So one side, the activity cost will increase. At the same time, project is completed as far as the fixed cost is concerned or indirect cost is concerned. Project is per day is 1,000. Sometimes 14 days, 20 days projects we can complete within 14 days. So therefore, the indirect cost wise, there is a cost will be reduced. Right? These two logic you have to understand clearly. The activity cost will increase, fixed cost or indirect cost will be reduced because that will reduce the total duration of the projects. Right? So these two ideologies are there. So you have to carefully distinguish these two aspects, otherwise you may get confusions. Right? So the second activity, say if you take B, 7 days, 4 days. Sometimes B is 7 days and 7 days. That means we cannot produce the activity B. That is also possible. Sometimes some activities cannot be crashed. Sometimes here also 7 days, here also 7 days. So that means the same durations required. That is also possible, right? But here B is reduced by 3 days, but cost increased by 3,000. So 3,000 divided by 3, then per day cost is 1,000. This is called a cost law. Likewise, all the activities you can see C, D, E, F, G. That is possible to reduce duration. It may be critical activities or non-critical activities. So then, based on the crash duration, we have to do the diagram. Based on the crash duration, the diagrams. Network diagram, only the duration is going to change. By drawing it, there is no changes in the structure of the network diagram. But only element is duration is 6 is going to become 5, 5 is going to become Hello students, can you see the screen?
Yes, sir.
Sir.
Hello? Yes or no?
Yes, sir.
Yes, sir.
Right? So that based on the crash durations, we can do the calculations, right? So that is the network diagram we have drawn, right? This one. Right, for this one. This one, right? Right, about this red color ones, huh? That is for that calculation purpose. Normally taking 13 days, no? Friends, crash duration is taking 13 days. That is the minimum durations. So note somewhere that crash duration is the minimum duration of the project. Beyond that, we cannot predict. So that crash duration is the minimum duration. So according to the statistics given, so you see that A activity A 543, and also in the table you can see here 6,000 is there. This 6,000 include this 4,000 also. Additional is 2,000, right? You have to understand this logic clearly. Yeah? Here 6,000 is there for the activity. Normal cost is 4,000 plus additional cost 2,000. That's become as a 6,000, right? Okay, here 7,000 normal cost, additional cost 3,000. That's become 10,000. So then, if you look at here 54,000, what is the extra total increase? Extra total increase how much? For the whole activities, extra increase how much, students? Hello, students. Students, are you here? Or just recording and leave it? Yes. What is the extra cost for this crashing for the project?
14,000, sir.
14,000. 54 minus 40,000. Okay. 54,000 minus 40,000. That is a 14,000 extra. Within the normal duration is a 20,000. Now fixed cost is how much? So after crashing, what is the fixed cost? Students, after crashing, what is the fixed cost?
13,000.
13,000. Yes, fixed cost is a 13,000. So normally students make a mistakes. 13,000 plus 54,000. How much? 13,000 plus 54,000. How much? 67,000. Right? Say what is the cost for the minimum crash duration? They will say 67,000 because this 54 plus 13 days into 1,000, 13,000. Altogether there are 67,000. That is the mistake they are making. So the minimum durations we can easily calculate. Right? You see the minimum duration is 13 days. 13 days we can calculate. But now according to the statistics, you see this is 67,000. Right? 67,000. Right? You can easily calculate 13,000 into 13 into 1,000. Right? Plus 54. Right? Plus 54. That is 67. At the same time, we have to carefully think about it. Project duration is determined by the critical activities. Right? This is a key point or focal point. You have to note it in your own language, or you can somewhere you can make a note of that. Right? Right? What happened while we are crashing? While we are crashing all the activities, sometimes non-critical activities like A, D, C, right, and G, also we have reduced the time. Right? Also we have reduced the time. But those are not necessary. Those are not necessary. Those are unnecessary things. So unnecessarily, right, we have increased the cost. Unnecessarily, we have increased the cost by reducing the duration of non-critical activities. Right? Unnecessarily, we have increased the project duration by reducing the duration of non-critical activities. That is a key point you have to know. So therefore, we have to make that adjustment. Say for example, A is already placed. Now we have to make it as a 2 days. This is not necessary because you see here at this point, at this focal point 4 junction, you see if you come this way 2 days, if you come this way 4 days. So therefore, this 4 we can add, 2 we can add. So then we can reduce the cost by 2 days. Remember, reduce by the cost by 2 days, because by adding activity, cost can be reduced. By adding the duration, cost can be reduced. By reducing the duration, cost can increase. The activity cost. Okay, therefore, in this context, we have add these two again. Therefore, 2,000 we can serve. Similarly, if you look at D, right? D also, you see what is the duration of D? 1, 2, 3, 4, 5 days. Normal duration 5 days. We have make it as a 3. But here 4 plus 5, 9. 4 plus 3, 7. So therefore, these two also we can add. These two also we can add. Right? These two also we can add. So adding 2 here, it's become again normal duration 5 days. Then 2 from that also 2000 we can serve it. Okay. Right. Now we have to look into that C. C how many days? 1, 2, 3, 4, 5, 6 days. We have reduced it 5 days. So this is not necessary. This is also we can add. Because you see in this point is a 9 days. 5 plus 1, 6. So then there is 1,000 rupees. It's a cost slope. Huh? But if you look at the G how many days? 1, 2, 3, 4, 5 days. We have reduced it as 3 days. But we cannot add all 2 days here. Because if you add that one, the critical path will change. So if you add 9 plus 5, how much? 40. Okay. 9 plus 5, 40. So that is wrong. But we can add 1 day here. Right? But we can add 1 day here, not all the days. So therefore here, remember this is a special case for the G, activity G only. For the activities G only, we can add only 1 day, not all 2 days. Because we have to look into without violating the critical path, we have to make this adjustment. Right? So why we are not add all 2 days with the G? Because if you add that one, that will increase the project duration by 14 days. Right? Project duration by 14 days. So that is not good because that is violating the critical path rule. So therefore we cannot add all 2 days. Right? All 2 days. That's why we have to add only 1 day with the activity E. So therefore you have to make it as a remark somewhere. So later you may forget about it. Right? So why we are not adjusting all 2 days again in the activity B? Because, right? Because of this issue, because it will violate the critical minimum duration of the projects. Within that minimum boundary, 13 days, we can make adjustment. That is the thing you have to learn. So that's why 1 day, therefore it's 1,000. So if you add all these things, 2,000, all these things in the black colors, 2, 2, 4, 5, 6,000. So this 54, right, we have to minus 6,000. Because this 6,000 is unnecessary, increase the cost. So after reducing this 6,000, right, after reducing this 6,000, then it's become 48,000. 54,000 minus 6,000, it's become 48,000. Plus indirect cost or site cost or a fixed cost also we have to add 13 plus into 1,000. 13 into 1,000. Right? So now the total cost become 61,000. 61,000. Otherwise, directly from 67,000, you can minus this 6,000. That is also 61,000. So, anyways, you can do it, no problem, right? 67,000 minus 6,000, right? This adjustment 6,000, then that becomes 61,000. So, in both way, we can calculate. So, therefore, these are the idea behind the minimum durations and associated cost. So the minimum duration is 13 days, associated cost is 61,000, not 67,000. You have to understand the realities behind how we have made these adjustments. Okay. Any doubts on this area? Hello students, are you here?
Yes, sir.
Okay, any things you want to clarify further? Okay. So and after that, the third one, right? Third one is about the first one is about normal duration, normal cost. Second one, minimum duration, associated cost. Third one is about minimum cost, right? Minimum cost and associated durations. Minimum cost and associated durations. Right? That is the third calculation process. So this is relatively, third one is relatively difficult, right? When compared with the first. The second one is difficult when compared with the first. Third one is difficult when compared with first and second. Difficult in the sense you have to really understand what is really happening inside the process, right? Inside the process. Otherwise, difficult to manage. There is no very specific standard methodology to learn, but by understanding only the realities, we can do these calculations, right? Like transportation, sometimes transportation assignments, even without understanding, we can do it if you know the methods or the procedures clearly. But here, we have to critically think, right? We have to critically think in this section. So the third one is about minimum cost and its associated durations. How to find this minimum cost? So remember, the first one is normal duration, normal cost. Second one, minimum duration, associated cost. Associated cost, remember. It's not the minimum cost, minimum duration, associated cost. Can you see the word file, students?
Yes, sir.
Right. Third one, starting with the cost, minimum cost. The particular minimum cost, right, from by starting with the cost activities, then we have to check what is the durations. Starting with the cost, reducing the cost, step by step, find what is the duration associated with that, right? That is the logic, right? So starting with cost, normal cost, right? Starting with normal cost, right? We are moving towards what is the durations, right? Actually, when from the normal duration diagrams, we are starting the process for the third one. Normal duration diagrams, we are starting the process. We are considering the normal cost as a basic amount for the calculation purpose. From that, we try to minimize it. What has happened? Cost is minimized, activities also, duration also will decline. After a particular level, right, after a particular level, cost will increase. Starting with the normal cost, right, starting with the normal cost, right, this is starting with the normal cost, we start to try to reduce the durations. Then after a particular point, again, cost will increase. So this is the minimum cost, right? This is the minimum cost. So you have to understand what is reality meaning of the minimum cost. And in that cost, what is the duration of the projects? So in that cost, what is the duration of the projects? So that's why we are starting with normal duration diagrams. You see here, we develop a table like this: activities, path, critical path, cost adjustment, adjusted cost. Right? So we have already identified all the paths P1, P2, P3, P4, P5, P6, P7, P10. Right? The normal durations, actually P10 we don't need to consider about it because that is less than our minimum duration. The minimum duration how many days? 13 days, no? This is less than that. Therefore, we don't need to consider about P10, but anyhow, I have incorporated that also, right? 10 part. Because why we don't need to consider about this one P10? Because the duration is less than the minimum durations. P2, P9 also we don't need to consider because it's a less than the minimum duration. These two parts we don't need to consider about, right? Other part we have to consider about it. You see, until the last process there is no any changes. Basically, there is no any impact. So anyhow, we have to incorporate it. Then we have to put the normal duration 15, 14, 17, 16, 18, 17, 20, 19, 12, 11, 11. So the critical path is P7 because this is the critical path. Right? P3, sorry, critical path is 20, P7, right? P7. So all these informations we got it from the normal durations. Normal duration cost is also 60,000, 40 plus 20, 60,000. So carefully understand this, right? So up to this, no problem. You can decide it and you can put it. After that, right, we start our process from critical activities. So the minimum cost, right, the minimum cost, minimum duration, we start with the non-critical activities. Here, we have to start with the um, we have to start with the critical activities. We have to start with the critical activities. Okay. So think about it: B, E, and F. Think about B, E, and F. So the B, you see that right, from the normal duration diagrams. I have put it here. From B, you see that right altogether it's actually it's while we are starting it's 20, right? 20 I have made adjustment, that's why this is shown here. Right, B is a critical activity. So you see that we have reduced 3 days, possible to reduce by 3 days, right? So therefore it's here 4 days, here also 7 minus 3, that is 4 days, no issue on that. All right, 4 plus 5, 9 days, right? 4 plus 5, 9 days. Before we make these adjustments, right? It's better, I think I can redo it, no? From the normal diagrams. I'm redoing, yeah, just for that, the normal diagrams, and you can understand this. Right, now you see that for the B, right, activity B, we starting with the B because there are only 3 critical activities, right? Here, B, E, F, right? B, E, F. So therefore, I'm starting with the B because all the core slope are same. If the core slope are different, then treatment is different. Understand that also. Which is the highest one, we have to consider first priority, right? Okay, be careful, huh? That is also there. So therefore, here there's no problem, all are same core slope. Therefore, we start with the B. B we can reduce 3 days minus 4 days, right? So 3 days reduce, so possible to reduce. So what will happen? We are reducing it, right? We are reducing minus 3, right? Now you see that now it's going to become how much? 4. Now it's going to become 4. 4 plus 5, yeah, 9. Okay. Here 7 minus 3, 4, no, 4 plus 7 is 11. 11. 11 plus 6, 17. So at this point, 17 is the project durations. So now we have to look into the cost effect. By reducing these 3 days, what will happen? Here B activity B is not there, part 1 same as 415. Here no, same as 14. Here 17, no changes because activity B is not there in that part. Here no changes. Here 15 P5, 18 minus 3, 15. 17 minus 3, that is 14. 20 minus 3, that is 17, right? Then here also they are 19 minus 3, 16. So now critical path are 2. You see this one and this one. right? This one and this one. So P3 and P7. P3 and P7. So what is the effect on cost? This particular activity B, by reducing 3 days, it increased by 3,000, right? And also project duration from 20, it's become 17, then cost will be reduced by 3,000. The rate of increase and rate of reductions, right, same. Therefore, if it is a different, this figure will change. We understand it, huh? For easy understanding, I take this example, there is no changes. So, say the cost reduction is 4,000, increased by 3,000, then it becomes 59,000. But here there is no change. Increase also same rate, reduction also same rate. Okay, it's the 60,000. Then now you see this is 70 days. So the table and diagram should be matched, right, at this point. So then if you take critical path is E. E, how many days we can reduce? 2 days we can reduce. 7 become 5. So E, you see I'm going to reduce E 2 days. What will happen? Minus 2 days. Then you can observe the changes, right? So 4, then now is 5, become 9. Because 7 minus 2, right? 7 minus 2, 5. Okay, 7 minus 2, 5. 5 plus 4, 9. 5 plus 4, 9. 9 plus 6, 9 plus 6, 15. Right? Here 9 plus 14. Here also. Okay. Now you see that project duration become 15. So the effect of the cost and changes. E is reducing by 2 days. You can put the 3, this is 3 day, 3 days. This is 2 days. This is 1 day, right? So by reducing E by 2 days, the first part there is no E, second part no E, third part is E is there, therefore 17 minus 2 is 15. Part 2, right, E is there, therefore 16 minus 2, 14. P5 no change, P6 no change, P7 17 minus 2, 15 because E is there, P3, P8 14, 16 minus 2, 14, likewise. So now, again, now you see critical path P1. So remember, in this work, critical path should be remain as critical path. Non-critical paths can become as a critical path. Okay, that is a rule you have to apply. Critical path is critical path. Critical path cannot become as a non-critical path. But non-critical path can become as a critical path. So now you see the first steps, only P7 is a critical path. So after second work, P7 and P3 is a critical path. After this adjustment, critical path P1, P3, P5 and P7 because all are 15, highest one. But the cost wise, 2 days no, per day 1000, 2000 increase, fixed cost reduced by, this is about the fixed cost, right? This is fixed cost. This is also fixed cost. You note it easy to understand it. Huh? Hello students, are you following?
Yes, sir.
Okay. And this is also fixed cost. This is the activity variable cost, direct cost. So by E2 days, cost increased 2000. The project duration reduced by 2 days. Therefore, fixed cost reduced by 1000 into 2 days. So there is no any adjustment in the final cost. Right? Now, the last one, F. Now you see F is how many days we can reduce in F? According to the table, it's a critical activities, 2 days we can reduce. But we have to check whether possible to reduce all 2 days. If you take F, because here you see 9 plus 5, 14. If you look at this part, 9 plus 5, 14. Therefore, here we cannot reduce 2 days. Only we can reduce 1 day. Here you can understand the critical path cannot become non-critical path, but non-critical path become critical path. Here already this is a critical path. That's why I am unable to reduce all 2 days, only 1 day to equate it. So therefore, 9 plus 5, now 14. Here 9 plus 5, 14. Right? So only F is there, this changes is there. So make a remarks on why we are not reducing all 2 days. Because the reason is the current critical path cannot become non-critical path. That is a violation. But non-critical path, the non-critical path can become as a critical path. So therefore, with that principles, now you see we are making adjustment on that. 1 day, so therefore here 15 F is there almost in up to 8 paths, right? 40, 15 minus 1 day, 14, it's no changes. 15 minus 1, 14, 14, there is no changes. 15 minus 1, 14, 15 minus 1, 14, 14. Here also they are, therefore 12 minus 1, 11, there's no changes here. Okay. So if you draw these activities properly, you can see the changes here also. You can see the changes here also. Right? Okay. So now you see that cost wise again, the critical paths are now become almost go this way. This one is only non-critical path. CG is 11 days. Right? So the cost will increase by the activity cost by increase by 1000, fixed cost will reduce by 1000. So therefore no changes. Right? Therefore no changes. So in the cost again, cost remain as 60,000. Right? Okay. Now there is no further reductions because we see all these become as a critical path. Right? So hereafter there is no chance for doing adjustment. So this is a final state. So therefore now project duration is how much? 14 days. Right? But in that point, the minimum cost is 60,000. Or at the just minimum cost 60,000. Associated duration is 14 days. Right? 14 days we have reached. So therefore this is a little bit complex. You have to do the first example by your own, right? Try to understand or learn the principles. Then you can apply to other sums and past papers and etc. You can get the real understanding about this. Okay. So a real understanding about this. So now you see that these three, anything students you want to ask from this? One 131 participants are there. Students, do you have anything you want to clarify or any doubts? Right, your exams are very closer to that. So if the January is finished, then we have exams. Almost one more sections are there, one or two sections there. Right, so I can finish it all the section even within this week or next week. Right, okay. So now you see the summary. Students, can you see any doubts? Please ask me. Can you see the summary table?
Yes, sir.
Okay.
Yes, sir.
Okay, you see the summary table, normal duration, normal cost 20 days, total cost 60,000. There are two components, direct cost or activity cost, or fixed cost or indirect cost, right? How it is there. Then from the normal days, we have reduced the crash duration or minimum duration and associated cost, that is 13 days. It's become 61,000. How it's become 61,000? This is 48,000, 54, the adjustment 6, 48. The cost will increase 8,000. Right? This 8,000 increase. That's why it's 48,000. Here the fixed cost will reduce from 20 to 17. The increasing rate is 8,000. Reducing rate is the 7,000. The additional difference is 1,000. That's why it's become as a 61,000. Again, you see that minimum cost is a 60,000 remain as a normal cost. You know all these calculations we have did very detailed way in the table, because the rate of increase or rate of reductions between these two trade-off same, therefore it's not effective. Therefore it's not affected, right? So therefore it's not affected. So we have did that. So then the summary table, you see that minimum cost is 60, right? In this example, minimum cost as well as normal cost is the same. You see that? And associated duration is 14 days. You see that normal duration is 20 days, but associated duration is 14 days. The cost wise is increased, the direct cost increased by 46,000, but this cost reduced by 14,000. So therefore, same rate of increase and reductions. This analysis we have to understand it. Because in a various way, if you think, you can get a better picture about the complexity of the problems. That is about management science. So why it is 20 days, 60,000, 14 days also 60,000. So important questions. Why 20 days, 60,000? 14 days also 60,000. Why? Because of this cost, this sort of two components in the cost. They are deviating or adjusting in a different way between them itself. Therefore, this has happened, right? This has happened. Okay. So that's how it's solved. So already we have learned, and anyhow I have to refresh again with that. So this is about almost the network. You can approach the past papers and practice it and learn about more. Okay, any doubts? Students, if you do the past papers, practice the past papers, do the past papers, and try to understand it. If there are anything you can bring to the class, and you can ask the doubts, right? Then I can sort it out. Don't wait for a last moment because it's a disadvantage for you, right? So this subject you cannot learn in the last moment of these exams, right? And also the important thing is the time, right? You have to practice, then you can do the calculations quickly, right? Sometimes you may know about it, but you don't have a time to do that. So that is, right? You can understand the effects. You know it, but you don't have the time to do it during the exams because you are not practiced well. Therefore, you don't know how to save the time, how to manage the time. Therefore, you are unable to manage the exams only just doing one or two sum and that, right? Because 3 hours is quickly moving. Right now, you see, I have started this class, right? So 10:30. Now it's almost at 12, right? So I have explained only one sum. You have to do it 5 sums within 3 hours. So you have only maximum 30 to 35 hours per sum. Because reading, understanding is also taking sum, the 5 into 30, right? You see that. So therefore, you have to manage the time. How you can manage the time? You have to practice it. Every day you have to set the time and do it. Then you can improve your speed and etc. Then you can be able to manage it. You can bring your own calculator for the exams, please. Because we will provide the calculator. Sometimes there may be issues in that calculators. You can bring your own calculators, no problem. Right? Scientific calculators also you can bring it. Right? You can use it for the calculation purpose. Okay. So then I have given other sum also. I told these answers. Any doubts on that? Friends, please ask. If you are silent, then you will be suffer later. I have given these examples and asking to go and answers also. I told that. Anything you want to do it, students? Please raise. It's a more complicated part. Okay. Do you have any doubts? Students, please ask about it. This is the time for you, right? This is your class. You are here to learn. And if you are silent, it's not going to give any advantage for you, right? If you are silent, that is easy and good. Later you may realize, right? So therefore, please look into that. Otherwise, I will start the next sections. Okay. No doubts, no? So you have to ready for exams for the network anytime. Okay, right. So now I'm moving to next sections. It's about inventory management, so inventory control. It's a very important area in the management science, right? You have learned in various places, A level and WAT, CIMA, and chartered, and etc. So you may have a basic idea about it. Even if you don't learn A level, you have definitely learned business studies and all these things. So now it's with that basic things, we are moving to some advanced things. Basically, it's about the quantitative discount, right? Discounting factors and how to manage the discounting aspects. So that the inventory management or inventory control, all we know about basically the standard inventory models. We know about the equations, right? This is the equations. Right? Standard inventory equal square of 2DC over CH. Right? This is the standard express principles. For some models we have already developed. We can apply in a similar situation. Repetitive natures we can apply. Right? If the problem is repetitive natures, we can apply it. Okay, then you see that there are two costs related to that: ordering cost and holding cost, or carrying cost or holding cost. These are the two main costs in the normal inventory model. One is ordering cost, other one is carrying cost or holding cost. Right? So far you have learned about this one in A level or any other levels, right? Because you know how to calculate is total ordering cost, right? Total ordering cost, TOC. D, capital D is annual demand, Q is a EOQ, and CO is the cost per order, right? You know about it. So three parameters, three variables, three figures are dealing with this total ordering cost calculations. Total ordering cost is equal, D is about annual demand, Q is about EOQ, and CO is about cost per order, right? It's a cost per order, right? Cost per order. So then if you substitute the values, you can get the total ordering cost. If the D is given, you know the Q, and CO, cost per order, is given, then you can just substitute and get the total ordering cost. So this portion, D over Q, right? D over Q, only this one, D over Q is equal to N. Capital N stands for number of orders, right? Or note it somewhere here. Capital N stands for number of orders. Right? It's about N is equal number of orders. Number of orders. So number of orders in has to multiply by CO, cost per order. One order, what is the cost per order? Then that way also we can calculate total ordering cost. Right? So sometimes if it is N is given, number of orders you know, right? Cost per order is there, then you can calculate the total ordering cost. So D over Q is equal N. That is obvious from this one. right? This is a full set of informations about ordering cost. Okay, this is a full set of informations about ordering cost, right? Anything you want to clarify?
No, sir.
Then I am moving to carrying cost or holding cost, right? That is about total holding cost is equal. Q means EOQ, economic order quantity. That is half divided by half average. CH is about carrying cost per unit per annum per year, right? So if you multiply here, divide and multiply, then you can calculate the total holding cost. So there is another formula. This is sometimes it's needed, note somewhere. Total holding cost is equal DCH, carrying cost per item per year, and 2N. N is number of order, 2 is the number, right? 2N. Because this is also the way, one of the another way, one alternative way to calculate total holding cost, right? Alternative way to calculate the total holding cost. So carrying cost and holding cost, right? Carrying cost and holding cost, right? Different names people may use it. You have to be careful about it. Here we have to use it, but the notation skills I am teaching for that, that is useful because marking skills, everything is based on that. So as far inventory cost is concerned, so far what you have learned, the total cost of inventory is equal these two, total holding cost plus total ordering cost. That's you have learned. I am repeating what you have learned in A level and some other places. That's a basic. The total cost of inventory is equal total ordering cost plus total holding cost, right? Okay. So the total cost, so here total cost means total inventory cost is equal ordering cost plus carrying cost. Based on that, this model is constructed. I will show it how this model is constructed simply. By differentiating also we can see how we can get it. Just simply cross multiplication also we can see how it's getting. So this is the standard EOQ formula. This is model is constructed. Same problem we can use it repeatedly. There is no issue on that. So that is this is a very good example for a model. In chapter 2, you learn about the model, right? So I have given a material, please go through it, right? Model, modeling, etc. So that all these parameters, D stand for annual demand. Sometimes be careful, sometimes they will give monthly demand or weekly demand. Then you have to multiply by, if it is weekly demand, 52, monthly demand is 12, then you have to get the annual demand. Otherwise, you will get a wrong calculations. So sometimes they will give a daily use, small d. Small d is a daily use. Daily usage. Right? If it is d, small d information, daily usage is given, then you have to say working days, multiply by that, then you can get annual demands. So CO mean ordering cost, CH mean holding cost or inventory cost per item per annum, and N means number of orders, right? So now you see that according to that diagrams, how we decide Q for economic order quantity. This is a pattern of ordering cost. Less order, right? less cost, more order, more cost. Right? So that ordering cost patterns are going like this. The holding cost, when the quantities increase, stock holding cost will increase. So it shows as a 45-degree lines, but it's not exactly same, but it shows that. So that the total one is that, right? Hello?
Hello?
Yes. The total one, total cost shape is like this, right? Now you see that. Please mute and talk, students.
சும்மா போறீங்க
Form 2, you are not muting. I have muted. So you see that how you attentively involved in the class. Okay, it's everything is for the up to you. Alright? Everything is up to you. You will cultivate the results. That's all. So now you see that the total cost pattern is like this. Right? You have learned many places this one. I think today only you may understand why it has happened, how it has decided. So people will say EOQ is decided where holding cost and ordering cost are minimized. In that place, the total cost minimum is the EOQ level. Right? So that is the logic. Now you see that total ordering cost is equal total holding cost in that point, this cutting point. Right? Total ordering cost is equal total holding cost. Okay? Right. This you may not learn earlier, right? So be careful. This is about proving how you got it. Total ordering cost equal total holding cost according to the normal simple inventory control systems. Where that EOQ is decided, total cost minimum is that point. So this cutting place is TOC equal THC. So now equations wise, this is the equations for total ordering cost. This is the equations for total holding cost or carrying cost. So both should be equal. Now if I cross multiply, so the two, right? Now I'm going to cross multiply, right? You see carefully. Sometime exams, the people will ask about it. Examiners may ask about cross multiply. These two as well as this Q. What will happen if you cross multiply? So 2DCO, if you multiply by 2, this is 2DCO. Here, Q into Q, Q square CH. Okay, students, please understand cross multiplication is very simple one, right? Just 2 multiply by this one, Q multiply by this portions, Q square CH. So if you cross multiply, you will get this form. 2DCO is equal Q square CH. Right? So I am deriving from this diagram. So I'm coming to these conclusions. From this conclusion, I am going for detailed calculation formula for each component of the cost. Then where the total inventory cost is minimum is the EOQ will be decided. That is our understanding. So therefore, just I cross multiply these two. Then you see 2DCO is equal Q square CH. Now we have to find the Q. So the change in the portion Q square CH is equal, right? Equal to DCO. Now we have to find the Q now. EOQ, OQ. EOQ, OQ. Right? Now we will see that we have to find Q square 2dCH 2dCO into CH, right? I divide this one, that's all. Then if you want to find the Q, the same things, right? I put it square root of 2dCO over CH. This how the normal EOQ equation is derived, basically, right? So it's very easiest one, right? Anybody can do it. By differentiating also we can do it. Just by cross multiplication also we can come to a conclusion that how we can derive this EOQ formula. Right, so far you may apply the EOQ with respect to the COC over CH. So okay, no problem. Sometimes you may apply without knowing that, but you don't know how you have derived it. The derivation, so the getting of this formula is starting from this one. You see the graph shows, the diagram shows how this course pattern, how these course patterns are moving, right? How these course patterns are moving. Okay. So that in the course movements, you see POC is equal to HC, that should be equal because they are the total cost is minimized, that EOQ is decided. That's why it's COC equal to HC. Then D over Q, this is now I'm introducing again formula what you have already learned. Very simple one, right? This one, right? This one I'm using. Then CH also, total holding cost also Q by 2 into CH, average stock into EOQ into CH. So just simply the cross multiplications. You know the cross multiplications logics, denominators, right? Cross multiplications. So 2 is multiplied by these upper portions, Q is multiplied by this. So therefore we get it 2dCO equal Q square CH. And we have to find the Q, that's meaning of Q. Then Q square CH equal 2dCO. Then Q square is equal to 2dCO over CH. Then we have to find the Q is equal square root of 2dCO over CH. Right? Very simple. Okay. Anything you want to ask from this? So the 2024 you have to very working more hard, and because everything is closing, your exams and things, so we have to very systematically start to work on. Right? Anything you want to ask, because many exams I have conducted, you got 4 marks, right? Some say exams are there inventory network, so even if you not score that also, then out of 35 you will get 5 or 10 or some people as a minus marks also. You know about the story, right? So you have to very seriously work on this, otherwise you have to repeat the subjects, right? Okay, now we will come to our business. Now it's anything you want to clarify, students, for this? Okay, now do this one. Example 1. Can you see the table, that word file, students?
Yes, sir.
Okay. Example 1. D is 25,000 units. CO cost per order is 1,500. CH 3 rupees. Price of the product is 20 rupees. Find the EOQ. Question is find the EOQ. Right? Question is find the EOQ. and total inventory cost, including the purchasing cost, including the purchasing cost. Okay, that is the question. Do it quickly, 2 minutes, and say the answers. Okay, what is the answer? POP is 5,000. What is the total cost, including purchasing cost? Okay, MS 140, MS 140, MS 106, Form 144. Okay, your answers are correct. What is the total inventory cost, including purchasing? MS 06, okay. I think only five or six people are there. No? Yes, what is the total inventory cost, including purchasing? Total inventory cost, including purchasing cost? Quickly. Total inventory cost is 15,000. How much total purchasing cost? Total inventory cost, including purchasing cost. The wrong answers. 25,000. Your answers are wrong, students. With not 15,000. Please check. Find the total inventory cost, including the purchasing cost. MS 146. MS 146, may I know your name, please?
Niveda, sir.
Niveda, please check your answers, right? Because 25,000 into 20, how much? The purchasing cost equations what? The purchasing cost. Total ordering cost means the total purchasing cost plus total ordering cost plus total holding cost. Total purchasing cost how much? Total purchasing cost calculation formula is D multiply by P,
Price of product.
price. So how much? That is 25,000 multiplied by 20 rupees. That is 5 lakhs. How much total ordering cost? This is only 5 lakhs. Right? Total ordering cost how much? Total holding cost how much? Just tell me that total ordering cost is 7,500.
7,500, sir.
Okay, then other that one also 7,500. Then how much total cost? 5 lakhs plus 500,000 plus 15,000. 515,000. Okay, right. Total holding cost for from 144 is 1,500. So the correct answer is 5 lakhs and 15,000. Right. So this is the answer, right? Check your answers that total ordering cost is 25,000 divided by 5 into 1,500, that is 7,500. Right? The same way that 5,000 5,000 divided by 2, 2,500 into 3, that is 7,500. Right? You want to apply these equations also same as 25,000 into CH is 3. Then 2n means n you know about, it's dividing this 25,000 divided by 5, that is equal n number of orders. So in the same way that same equations, different equations, same answer, that is the okay. So the purchasing cost 5 lakhs 500,000. So answer is 515,000. Okay. Right. So then you see that So in inventory cost, which is the highest portion normally? Percentage wise, which is considering highest portion in inventory? In this example, you can see that which is the highest amount.
Purchasing cost.
Yes, purchasing cost. But so far in our learning courses, we are in our inventory calculation courses, we are not bothered about it. We are not worried about just only looking into ordering cost and holding cost. So the management science, you have to understand it incorporate the purchasing cost as well because it has a big amount, right? It's also relating to getting inventory, keeping inventory, right? Getting in without getting inventory, we cannot keep the inventory, right? So the purchasing cost also consider with the total cost of inventory, right? Because inventory value is a must. Ordering cost is also must. Holding cost also must. So the total inventory cost means, or inventory value means, inventory cost means, including the purchasing cost. That is the important point you should remember from these sections, or management science, or the quantitative techniques, or decision science. When you are doing for this inventory related things, you have to understand these realities. Okay, right. Um, okay, now can you do it this quickly? Right, the same things you have to do all these calculations and give me a 2 minutes. Students, yes, what is the answer? Sir, can you from 123? Yes, sir, can you do another questions in network analysis lessons? Yes, I have did that. Students, I have given second one also, no? I think today you have joined after a long time. Hello, students. Hello. Yes, commerce 123. Are you here? From 123. Friends, if you ask asking that, you have to reply that. Otherwise, it's not good for you also and good for me also. From 123, are you here? Yes, what is the answer for this one, students? And Indian, yes. MS1, MS146. Okay, right. Okay, student. Yes, so MS from 123 for your questions. I have given the second examples also, right? This one, the inventory management, this sum. Please do it, and if you have any doubts, please ask me that. I have did that, right? So this network diagrams, and some of you have given answers also. If anything you want to repeat, you can say in these sections. And also you can do the past papers and bring this, bring your doubts or the questions or anything, clarities, right? I hope some of you have did that, and if I fail to do that, you can say about it. Students, did I complete this second one? Others, Niveda? Hello, Niveda, are you here? Hello, Niveda, MS 146.
Second one not complete, sir.
Not completed. So normal duration, normal cost we have completed, no?
Yes, sir.
Crash duration,
Diagram not complete, sir.
crash is not completed. Crash one,
Not, sir.
okay, okay, I will do it next class. Okay, right. So what is the answer for this one? So here the CH has given the percentage of the price, not directly given. So then it is 2 rupees, 10% of the price also given. So you can calculate, right? It's about, right, EOQ is 6,124, right? The purchasing cost is 250, 225,000 into 20. Then ordering cost and holding cost are same because in the EOQ, right? That is one of the assumptions that based on that the model is working. So that's why it is, okay? Right. So I will stop at this point. Today 1:30 I'm not going to take it. Please check the Selamis, huh? If she is willing, she may take it. They know classes for 1:30. Okay then. I will repeat again this second examples of network. Right? Don't worry about that others. Right? Second examples again I can repeat, no problem. Right? Okay. Thank you very much. Again, I am wishing all of you, right? So that consider 2024 as a very challenging year, and please prepare for it and work hard and ensure your success. Thank you very much.
Thank you, sir.
Thank
Thank
you,
you, sir.
sir.
Thank you, sir.
Thank you, sir.
Okay.